Hi everyone. In this lab, let us understand how to create a fan out and message filtering functionality. Okay. So in the decoupled architectural series, fan out is one of the architectural pattern for sending the messages between the components. When a component receives the messages and process it and it wants to send it to the upstream components who wants to consume this message, we use the fan out strategy. Now within that, not every listener in the upstream destination wants to listen to this message, right? They are only interested in specific message based upon certain criteria. So in that case, we'll apply some filtering to the message, maybe in the message body or the message attributes. Then send out the message only if the criteria is there. Okay. So let us understand how to create such architectures in this demo. So we have API gateway, which is front-ending the API. We have the ride management service, which is implemented as Lambda. And once the ride completes, it will update the DynamoDB table with the status of the ride. Okay. And then it will use SNS topic to fan out to various listeners. So one of the component is the customer notification service, which is also implemented as Lambda. And another one is the customer accounting service. Then the third one is extraordinary service. So the third one is basically using a message filter. Okay, that means only if the fare is greater than or equal to X and the distance is greater than or equal to Y. Only if this condition is matched, then this filter will be valid. Okay, I mean the filter is true, then the message will be sent to the extraordinary service. Otherwise, all the messages will be sent to the customer notification and the accounting service by default because there is no filter for them. Okay. So what we will do is we will send a sample REST, curl call to the API gateway, and within the request payload, it's a post API. So we will send a JSON file which contains some fields. So the fields will use, we'll have from to fare distance and other metadata that is required for this application. And the request will go to the API gateway and to the Lambda to then to the SNS topic and then all other Lambdas. Then it will come back to the client, the response. So this is the end-to-end demo that we're going to demo in this lab. Okay, let's go to the code to see how to implement this architecture. So in this lab, let us understand how to write the code for the fan out and message filtering use case. Okay, so let's first go to the code. The first one we will look into is the API gateway. Okay, so this is front ending the clients. Okay, so we are defining one REST API using these resources. Um, the type of the API is a REST API and the endpoint is edge configuration. Okay. There are multiple options here. You have private, regional, and edge. So this is not specific to any regional. This is completely global. So when the request comes to this endpoint, it will send it to the nearest region-specific component um, to cater to customers across the globe. Now, within this code, we have one more resource, which is the resource gateway resource. Okay. Now, this is the resource that we are creating it. So slash submit write completion is the API, and the method is post, and there is no authorization to this. Okay. So there's no client authentication. And for the integration, we are using AWS proxy integration for the Lambda, and the method is post. Then we are creating one deployment, and if any one of these object changes, the deployment will happen. And for this deployment, we're creating a stage. The stage name is called prod. Okay, so this is a simple API gateway configuration, and I'm also using the CloudWatch logs for the API gateway functionality. Okay, so this is one. Second one is, let us go to Lambda. So Lambda, we have multiple Lambdas created. One is the write completion Lambda. So it is basically a Python code. The code is in this directory, and I'm attaching some policies here. The trigger for this API gateway. Okay, so this is API gateway trigger. Then I need to pass the DynamoDB table ID and also the SNS topic ARN as an environment variable to this Lambda. And the second one is the customer notification Lambda, which is also a Python code. Then the trigger for this is basically SNS, because SNS topic has to deliver this message, has to invoke this lambda. And so the table name may be optional here because you may not be using the table, but you can just ignore this for now. Similarly, for extra ride also, the trigger is SNS, and it's lambda based, Python based code. Then yeah, it's same as the previous one. There's not much difference. Similarly, the custom accounting. So, and there are some lambda policies that we are defining for the lambda role. So if I go to DynamoDB, so it's a simple table with the ID as the primary key, which is a string key. Okay, it's based on string type, and this is where the state will be stored. Then let us go to SNS. So SNS topic, we are creating it, and we are allowing any IAM principals to publish messages to this. And subscription to this, there are three lambdas. Okay, lambda 1 is basically the customer notification lambda, 2 is accounting lambda, third is extraordinary. So here we need to keep in mind the filtration policy, the message filter policies. The scope is attributes, so it is not the message body. The attributes we are filtering. So if the fare is more than greater than or equal to 50, the distance is greater than or equal to 20, only then this message will be delivered to this particular uh, subscription, which is basically a lambda, third one. Okay, so now what we will do is we will do Terraform init and Terraform plan and Terraform apply to deploy this code. Okay, so Terraform apply, let us do Terraform apply with auto approve. So Terraform apply is complete successfully. The output of the code is this. So the invoke URL for the resource that you have created. This is the name of the uh, API gateway API ID, and this is the region, and this is the resource that you have created it. Okay. Now let's first go to the console and see how the resources are created, and then we will come back to the console and do some testing. So this is API gateway console. So if you see, this is the REST API, and the endpoint type is edge. So here I have one resource. The name of the resource is submit hyphen ride hyphen completion, and I have one method configured for this. So the integration request, there is no authentication here. Authentication is none. So integration request, you will see it is connected to Lambda. So this is a Lambda that is connected to the API gateway, and integration response also, there is nothing here. Method response also nothing. Okay, the response is coming from the Lambda directly. Now let us go to the Lambda. Now this is a ride completion function. So the code base is quite simple. So it basically gets the message from the API gateway and validates it, sends a record to the DynamoDB, update the table with the record, and also sends a message to the SNS topic. Okay. So two things it will do. It will write a record into the table and also sends a message to the SNS topic. Now let us go to the other functions also. See, we have three more functions. One is the customer accounting, notification, and extraordinary write. So let us go to these functions and see what is the functionality they are implementing it. In the customer accounting, if you see, the trigger point is SNS. Okay. Now SNS is the one which is invoking this lambda. So the trigger is SNS. So it will simply print the message. Okay. It is not doing any extra processing. It simply print the message to the console. Similarly, if you go to the customer notification, um, there also the functionality is same. It is triggered by an SNS topic, and it simply prints the message. Okay, the message and message ID. Similarly, the extraordinary service also is the same, triggered by SNS topic, and does exactly the same printing. Okay, there is no code, there is no change to the code for the three lambdas. Okay, now let us go to the DynamoDB table also. before here. Let's go to the SNS first. So this is SNA topic, and you have 3 subscribers, and all of them are Lambda functions. Okay, we saw that, and only for one of them you will see a filtration. So if you go to the um, that subscription, which is basically the extraordinary service, right? So this is where you will see the filtration. So one of the filter is the distance has to be more than 20 and greater than or equal to 20, the fare has to be greater than or equal to 20. So only then the message will be sent to this destination. And for all other um, subscriptions, you don't see any filtrations. Okay, for example, if you go to this one, this is basically customer accounting, so there is no filter. Okay, and let us see the other one. So this is the customer notification. Here also there is no filter. Okay, now let's go to the DynamoDB table. So DynamoDB table is also very simple. It has just one key. The name of the key is ID type string. So now let's go ahead and test this entire architecture. Let's go to the console and send some commands. So first we need to get the URL here, and what I will do is I'll just change the value for the distance to be, for example, 5. Okay, and fare to be 30. So just to ensure that this is not sent to the third one, the extraordinary service Lambda. So let's first run this command. Okay, so we have sent this message and we are getting one ID back. Now let us go to the console and check. Let's first look at uh, let's go to the ride completion function. Okay, in the ride completion, if I go to the monitor and look for CloudWatch logs for this. So this is the latest message, and you see the message that we have received is distance is 5 and fare is 30. This is exactly what we have configured in the post message. Okay, so that means we are able to receive this message to this Lambda. Similarly, if I go to the other Lambda functions, right? For example, the accounting Lambda. Okay, let's go to the accounting. So accounting also, we should see the message because there is no filter. Okay, so if I just expand this, the last one, distance is 5, fare is 30. So we have received that. And notification also we should see customer notification. So here distance is 5, fare is 30. Okay, now let's go to the extraordinary service Lambda. Here you don't see that. Okay, the last message was sent around 2 o'clock, but the message we have sent at 3 o'clock, and this is a different um, message. It's not the one we've sent it. Okay, the previous one. So that means there was a filter applied at the SNS level, and the input message does not match the criteria, so the message is not delivered to this function. Okay, now let us go to the code and change this. Now I will change this to, let's say, distance to 40 and fare to be 100. Okay, just for the testing purpose. Now I will send this message to API gateway and see what happens. Okay, so message is sent. Now let us go to the extraordinary service first. Okay, now you see the extraordinary service received this message. Okay, you can see the distance is 40 and the fare is 1000. So looks like we have changed it to 1000. Okay, that's fine. So as long as the criteria matches, then the message delivered. Similarly, you should see this message in other lambdas also, because there is no filter applied there. So if you go to this log and the latest one, you should be able to see this. Okay, looks like some error occurred. I'll just check this. Actually, this is not an error. So what's happening is we still got the message here. Sometimes we are basically doing some error simulation in Lambda. The Lambda sends an error back. The SNS topic has to retry. So that is the reason we are randomly sending a error response from the Lambda. Okay, so this is not an issue. So you see the distance is 40 and the where is 1000. So that means we got the message. So similarly, you should be able to see this across other lambdas also, customer notification, for example. So there you should see, yeah, distance 40, where 100. So the next one is basically accounting. Also, we should be able to see that. Okay. So distance 40, where 1000. So that's how we can just create an end-to-end architectures using API gateway as a front end and Lambda to do the processing, and then it'll use the DynamoDB to save the state, and at the same time it do fan out by using SNS topic, which is meant for pub sub architecture, and at the same time we can do the message filtering as well.